So in the last lecture we studied about the concept of gravitation. Now in the new lecture we'll study about work and energy. So in that, first we'll start with work. So work can be defined in different ways in day-to-day life, but in the language of science, work is defined as whenever there is a displacement in an object due to the force applied on it will be called as the work. What I said, whenever there is a displacement in an object due to the force applied on it will be considered as work done. So the formula for which from which we can calculate the work done is into force into displacement. So whenever there is a force applied and due to that force there is a displacement in the object, it will be called as the work done, and the formula to calculate the work done is force into displacement. So when it comes to the unit of the work, force will be measured in newtons and displacement will be measured in meters. So work unit of work is Newton meter. In the gravitation chapter, we studied about Newton per meter square, and this was for the pressure. But here we have Newton meter, and the Newton meter is for work done. And 1 Newton meter is also equals to 1 joule. So the unit can be said as Newton meter or joule. So depending upon the direction of the force and the displacement of the object, we have seen that force has magnitude as well as displacement, magnitude as well as direction, and same goes for the displacement. These both the values will have magnitude as well as the direction. So depending upon the direction of the force and the displacement, we have categorized work done into 3 types. The first one is the positive work. So when we'll say that the work done is positive, when the direction of the force and displacement is same, like the force is applied from left to right and the object also moves from left to right. So in this case we will say that the work done is positive. So any example, we can say that if I have this marker placed on my palm and if I push it in this way, so this will cause a positive work to happen. Then in the second case we have negative work. And negative work is when the force and displacement are in the opposite direction. So when is this possible? If the object is moving from, say, left to right, from right to left, and the force is being applied from left to right, and because of this force the object comes to rest after traveling some distance. So this will be called as a negative work. Imagine stopping a car using the brakes. If the car is traveling in this direction and you apply brake, so brake will be applied in the opposite direction of the displacement of the car, because of which it will stop. So in this case the work done is negative. So we have discussed positive work, negative work, and the last one is zero work. So zero work is done when the angle between the displacement and the force is 90 degree. Means what? They are perpendicular to each other. Force and displacement are perpendicular to each other. So imagine carrying a bag on your back. Imagine carrying a bag on your back. So for example, if we have a person who is carrying some bag on his back, so what happens? This bag will be accelerating downwards because of the gravity, and the person will try to move in this horizontal direction only, right? So what is this angle being made between the direction of the weight and the movement of the person? It is 90 degree. So in this case zero work is done by the man on that bag. What I've said, zero work is done by the man on the bag. Is done by man on the bag. You can also imagine a coolie. Coolie is who? The one who carries the luggage of the people on railway stations, right? So the coolie is also doing zero work on the weight he is carrying on his head or in the hands. Okay, why? Because the angle between the direction of the motion and the force is perpendicular to each other. Even when you are standing on the ground, you are applying a perpendicular force, but whenever you will try to move, you will move horizontally, but your force will be applied downwards. So in this case you are doing zero work on the ground, right? Why? Because the angle is 90 degree. So this is how we have categorized the work. So once we have discussed about the work, the next topic is energy. So first of all, what is energy? Energy is nothing but the capacity to do work. मतलब the amount of work anything or any body can do is equals to the energy possessed by the object. If I am capable of doing 50 joules of work, I am having 50 joules of energy. Okay, so energy and work are exactly the same thing. Like if there is no energy, there can be no work done. If there is no work done, there was no energy involved in the system. If there is some work done, there will be some or the other energy which has came into play. So if you start imagining work and energy as same thing, it will be easy for you to understand the other concepts as well. Okay, so whenever we have negative work, energy is released. Energy is released. Whenever we have positive work, the energy is provided to the system. and whenever we have zero work, no energy transmission, like no energy has came and no energy has been released in the system. Okay, and the unit of energy is same that as that of the work. So we had 50 joules of work, so here we will also have 50 joules of energy. So SI unit of energy is also joules. And now we'll talk about the different types of energy. The different types of energy because of which we can say there is some or the other work done. So first in this is the kinetic energy. So whenever we'll say that any body has some or the other kinetic energy, it will always be because of the motion of the object. So what does the definition of kinetic energy says? The energy possessed by an object due to its motion will be called as energy. The energy possessed by an object due to its motion is called as kinetic energy. The kinetic energy पण काय आहे? It is a type of energy. So त्याचा युनिट पण काय होणार आहे? It will again be joules. कोणतीही एनर्जी आपण जर बघणार आहोत त्याची जी SI unit आहे, it will always be joules. Now the formula to calculate the kinetic energy, it is half mv square. The formula to calculate the kinetic energy is half mv square, where m stands for the mass and v stands for the velocity. Any object which is in motion will always have a kinetic energy, and any object which is at rest will have zero kinetic energy. Then the magnitude of the kinetic energy will always depend on the mass and the velocity only, and not on the direction. Okay, it can be in any direction irrespective of its shape and size also. जर तुम्हाला असं सांगितलं असेल की a circular object of mass this and a square object of mass this, काही फरक पडणार नाही. If the mass and the velocity of any size and shape of the object is same, it will have the same kinetic energy. Then we also have something called as the work energy theorem. So what does this work energy theorem says? So work done is equals to the change in kinetic energy. याच्यावरती सुद्धा तुम्हाला बऱ्याच वेळेस क्वेश्चन विचारले जातात. Change in kinetic energy. जेवढा पण कायनेटिक एनर्जी मध्ये चेंज होणार आहे, that will be equals to the work done, the external work done or the work done by the own object. Say एक कार चाललेली आहे, एक कार चाललेली आहे with 16 meters per second, and brakes are applied and it now comes down to 10 meters per second, right? And the mass of the object is say 5 kg, and you are supposed to find the work done. Work done to calculate to bring this change in the velocity of the object of 5 kg mass. इथं काय होईल? वर्क डनचा फॉर्म्युला काय आहे? चेंज इन कायनेटिक एनर्जी. आपण अगोदरच सांगितलं आहे चेंज कसा कॅल्क्युलेट केला जातो, नेहमी फायनल वेलोसिटी और फायनल व्हॅल्यू मायनस द इनिशियल व्हॅल्यू. तर आता फायनल व्हॅल्यू काय होईल? इथे फायनल व्हॅल्यू इज 10 meters per second. That For this 10 meters per second, we will have kinetic energy as 1 by 2 into 5 into 10 square, and final minus initial, and the initial kinetic energy will be 1 by 2 into 5 into 16 square. So this is 100 divided by 2 is 50 into 5 is 250, minus 1 by 2 into 16 square is 256. 16 square, 25, 15, 16, yes, 256 divided by 2 is 128, and 128 into 5 is 640. So 250 minus 640 is 390 with negative sign. So the work done is equals to 390 minus 390 joules. Now in this case we get a negative work done. So negative work done means what? The energy is being provided, sorry, released by the system. The system has done some work, because of which we are getting the negative energy. So this is how you will use the work energy theorem. So after the work energy theorem, we have the next type of energy, that is potential energy. So in kinetic energy, the energy was because of the motion, but in case of the potential energy, the energy will be possessed due to the position of the object. Example, a spring. If a spring is in this condition, and the first condition is the spring in normal condition, but now the spring is being stretched. Now due to this stretched position of the spring, it will contain the potential energy. It will be same for the water present in the dam. Water in the dam will also have potential energy due to its position, right? Whenever we bend any stick, if this is a normal stick, and if we bend the stick in this way, it will have a potential energy, and this potential energy is used to fire the bow and arrow, right? This potential energy is used to fire the arrow using bow and arrow, right? Dhanushya ban, this is what we call it in Marathi. आणि पोटेन्शियल एनर्जीचं सुद्धा इथे एसआय युनिट काय येणार आहे? इट विल बी सेम ॲज दॅट ऑफ द एनर्जी, दॅट इज जूल्स. आता आपण बघितलं की ही जी पोटेन्शियल एनर्जी होती, दिस वॉज बिकॉज ऑफ द पोझिशन ऑफ द ऑब्जेक्ट ऑर द स्टेट ऑफ द ऑब्जेक्ट. आता याच्यामध्ये काय होतं, स्प्रिंगला पण स्ट्रेच केलंय, वॉटरला कुठे ठेवलेलं आहे, आपण डॅम मध्ये ठेवलेलं आहे एका हाईट वरती. देन वी हॅव ऑल्सो बेंड दिस स्टिक अँड मेड अ बो आउट ऑफ इट टू फायर एरो, म्हणजेच काय, धनुष्य बाण बनवलेला आहे आपण. बट वी ऑल्सो हॅव अ पोटेन्शियल एनर्जी, potential energy due to height. आता हाईट मुळे पोटेन्शियल एनर्जी कशी येणार आहे तर आपल्याला इफ अन ऑब्जेक्ट इज प्लेस्ड ऑन द ग्राउंड, आणि आता याला मला एका हाईट वरती घेऊन जायचंय, मला काही ना काहीतरी फोर्स लावा लागेल, तेव्हाच ते ऑब्जेक्ट त्याची डिस्प्लेसमेंट घडून येईल. तर हा जो फोर्स आहे, द फोर्स विच रिक्वायर्ड टू द मिनिमम फोर्स रिक्वायर्ड टू लिफ्ट द ऑब्जेक्ट अबव फ्रॉम द ग्राउंड इज इक्वल्स टू द वेट, विल बी इक्वल्स टू द वेट ऑफ द ऑब्जेक्ट. द वेट ऑफ द ऑब्जेक्ट कसं निघणार आहे आपलं, एम इंटू मास इंटू ग्रॅव्हिटी. आणि जर आपण 1 मीटर वरती घेऊन गेलो तर आपण त्याच्या हाईटला काय करणार आहे, 1 मीटरनी मल्टिप्लाय करू. जर आपण 2 मीटर वरती घेऊन गेलो तर एम जी इंटू 2. तसंच जर आपण एच हाईट पर्यंत जर घेऊन जात असेल तर त्याची एनर्जी किती येईल त्याच्यामध्ये, एम इंटू जी इंटू एच. So in this way we calculate the potential energy due to height, and the minimum energy required to raise the object above the ground is equals to the weight of the object. आपण जास्त लावलं तर काही होणार नाहीये, but the minimum weight, so the minimum force required to lift the object is mass into gravity, that is the weight of the object. तर आता हे जे आपण घेऊन गेलो, आपण एक स्ट्रेट डिस्टन्स मध्ये घेऊन गेलो आहे त्याला. तर जर आपण या प्रकारे घेऊन गेलो तर काय होईल, इकडे एनर्जी जास्त असेल आता त्याच्यामध्ये की इकडे एनर्जी जास्त असेल, बिकॉज इन दिस केस इट इज ट्रॅव्हलिंग मोर डिस्टन्स. बट आपण जो फॉर्म्युला लिहिलेला आहे वर्क डनच्या फॉर्म्युल्यामध्ये काय लिहिलेलं आहे आपण, फोर्स इनटू डिस्प्लेसमेंट. इथे डिस्प्लेसमेंट किती आहे, तेवढीच आहे का जेवढी इथे होणार आहे. इवन इफ इट हॅज ट्रॅव्हल्ड मोर डिस्टन्स द डिस्प्लेसमेंट इज स्टील द सेम. जर फोर्स सेम आहे, डिस्प्लेसमेंट सेम आहे, तर इथे वर्क डन सुद्धा सेम असेल. आणि जर सेम वर्क डन केलेला असेल तर हे जो वर्क आपण केलेला आहे तोच नंतर कशामध्ये कन्वर्ट होत आहे, it is getting converted into the energy, and in this case the energy is the potential energy. So इक्वल वर्क केलेला आहे त्याच्यामुळे इक्वल एनर्जी मध्ये ते कन्वर्ट होणार आहे. सो इन दिस बोथ द केसेस द एनर्जी possessed by the object at this height will be same. Why? Because the work done is also same. Then we also have a concept of mechanical energy. Mechanical energy. The mechanical energy is nothing but the addition of kinetic energy and the potential energy. And the mechanical energy of any system is always constant if there is no external work done on the system. आणि आपण मेकॅनिकल एनर्जीचा फॉर्म्युला इथून काय लिहू शकतो, कायनेटिक एनर्जीचा फॉर्म्युला आहे हाफ mv स्क्वेअर प्लस पोटेन्शियल एनर्जीचा फॉर्म्युला आहे m इंटू जी इंटू h, and this always remains constant. आता याच्यावरती क्वेश्चन तुम्हाला फ्री फॉल रिलेटेड येऊ शकतो की इफ एन ऑब्जेक्ट इज ड्रॉप फ्रॉम अ हाइट ऑफ 200 meters, so what will be the potential energy and the कायनेटिक एनर्जी possessed by the object. तर त्याच्यामध्ये आयदर तुम्ही एक काढू शकतात आणि त्याला कॉन्स्टंट धरून दुसऱ्यात कॅल्क्युलेट केला जाऊ शकतो विदाउट इवन calculating it using the formula. Up next we have law of conservation of energy. Law of conservation of energy. तर लॉ ऑफ कन्झर्वेशन ऑफ एनर्जी काय सांगतं, the total energy before and after the transmission of energy remains same. म्हणजे त्याचा अर्थ काय आहे, इथे जेवढी आपण कायनेटिक एनर्जी लावू, इथे जेवढी आपण कायनेटिक एनर्जी लावलेली आहे तेवढीच कायनेटिक एनर्जी या हाईट वरती गेल्यानंतर त्याच्या पोटेन्शियल एनर्जी मध्ये कन्वर्ट होणार आहे. म्हणजे काय केलं आपण, एनर्जी ट्रान्समिट केलेली आहे फ्रॉम कायनेटिक एनर्जी टू पोटेन्शियल एनर्जी. त्याच्यामध्ये काय आहे, बिफोर जेवढी अगोदर कायनेटिक एनर्जी होती तेवढीच आपली नंतरची काय होणार आहे, पोटेन्शियल एनर्जी मध्ये कन्वर्ट होणार आहे. समजलंय काय सांगितलं याच्यामध्ये, तर की द एनर्जी, द टोटल एनर्जी बिफोर अँड आफ्टर, द बिफोर अँड आफ्टर द ट्रान्समिशन, ट्रान्समिशन म्हणजे काय, द कन्वर्जन, कायनेटिक एनर्जी इथे पोटेन्शियल एनर्जी मध्ये कन्वर्ट झालेली आहे. तर हे जे कन्वर्जन आहे, जेवढी अगोदर आपल्याकडे कायनेटिक एनर्जी होती तेवढीच आता आपल्याकडे पोटेन्शियल एनर्जी राहणार आहे. बिफोर अँड आफ्टर द ट्रान्समिशन इज सेम. And we can also say that the energy can neither be created nor be destroyed but simply transferred from one form to another. तर मग आता इथे एनर्जी आपल्या अर्थ वरती येते कुठून आहे, सो द मेन सोर्स ऑफ एनर्जी, द मेन अँड द बिगेस्ट सोर्स ऑफ एनर्जी, बिगेस्ट नॅचरल सोर्स ऑफ एनर्जी, natural source of energy is our sun. ओके, याच्यावरती सुद्धा तुम्हाला क्वेश्चन विचारला जाऊ शकतो. सो यू ऑल्सो नीड टू रिमेंबर दिस. देन वी हॅव रेट ऑफ डुईंग वर्क. रेट ऑफ डुईंग वर्कलाच आपण काय म्हणतो आणखीन, पॉवर, राईट. रेट ऑफ डुईंग वर्क, यालाच आपण काय म्हणतो, पॉवर. तो हा जो रेट आहे हा कशाच्या रिस्पेक्ट मध्ये पकडला जातो, इट इज ऑलवेज टेकन विथ रिस्पेक्ट टू द टाइम. सो मग आता इथून आपला पॉवरचा फॉर्म्युला काय निघून येणार आहे, पॉवर इज रेट ऑफ डुईंग वर्क, म्हणजेच काय, वर्क डन पर युनिट टाइम. यालाच आपण काय म्हणणार आहे, पॉवर. सो वर्क कशामध्ये, वर्कचं युनिट काय आहे, वी हॅव जूल्स, आणि टाइमचं युनिट सेकंड्स. सो पॉवरचं युनिट पण काय होईल, इज जूल्स पर सेकंड, और जूल्स पर सेकंड इज ऑल्सो कॉल्ड एज द वॅट. सो 1 joules per second is equals to 1 watt. Okay, we can say an energy, an object has 1 watt of power kadi when it performs 1 joules of energy in 1 second. And it is never necessary that if two objects have same power, if two objects have same power, they will possess equal amount of energy or they are capable of performing equal work. No. And it is also true vice versa, that if the energy possessed by two objects is equal, then they will have equal power. No, the power is dependent, also dependent on the time. Okay, so we can say that the object with greater power is capable of performing more work in less amount of time, and the object which has less power is capable of doing less work in more amount of time. समजलंय? जेव्हा पॉवर हाय असते, if power is high, the time required is less. Why? Because from this formula we can see that the time and power are inversely proportional to each other. आणि जेव्हा पॉवर कमी होते तेव्हा आपला टाइम काय होतो, द टाइम इन्क्रीजेस. ओके, जर एका दोन ऑब्जेक्ट्स मध्ये सेम एनर्जी असेल तर इट डज नॉट मीन दॅट दे विल हॅव सेम पॉवर. इट विल डिपेंड अपॉन द टाइम, की तेवढी एनर्जी युटिलाइज करायला त्यांना किती टाइम लागतोय, राईट. So this was all about the work, energy, and as well as the power. Okay, so with this our chapter work and energy also finishes.